Hello to the today's lecture on business research methods. It's actually an add-on lecture to the lecture we had last week about regression. What about if we have more variables or variables that are dichotomous variables that only have two expressions, like it's night or it's day, it's light or it's dark? What do we do with those variables? That would require logistic regression. You remember when doing a regression, we have two variables. We had creativity and centrality, and we have asked 100 people, so we have 100 data points, and we try to set a line up throughout all the data points which the shortest distances. That would be a regression. That is when the distances are bigger, the explained variance is not that high. When the points are closer to the line, the explained variances are higher. Today we will use the same variables, team tenure, how long have people stayed in a team. In years, we will use gender as variable with actually 3 expressions, male, female, and diverse. We will again go into social network analytics and look at this matrix, and it can be displayed like that, and it can be calculated as degree centrality and betweenness centrality between the lines and the points of this people in the team. Just look at the lecture on social network analytics and you will see how exactly we do that, but we can use it as a variable for centrality. And we again use creativity. You see it is once metric and once binary as dichotomous variable. The second one we will use for the logistic regressions, the first one we will use for the multiple regression. And as you see, it's almost normally distributed as a first test of this variables. So, dependent variable for our multiple regression, it's creativity, like at scale 1 to 7. For the logistic regression, we take a dichotomous part of this creativity variable as binary variable. We take 2 centralities, degree and betweenness, as shown, and we take 2 control variables, gender and team tenure. Going to a multiple regression. And at first, what you do in a multiple regression, you look at some correlations. Because if you have correlations among the independent variables, that means the variables that explain a dependent variable. As shown, creativity, metric or binary, is our dependent variable. So team tenure, gender, centrality, degree, betweenness explain creativity. And there we have to look for higher correlations. But it looks fine. We do not find many high correlations. High correlations would indicate multicollinearity. That means when 2 independent variables extremely highly correlate, we will get a problem with a regression, and a regression wouldn't be valid. Then we have to look for heterostochasticity. That means when you have 2 scales, like creativity 1 to 7, and degree centrality 1 to 100, betweenness 1 to 100. The scales have to fit and not lie next to each other. Then you cannot explain the dependent variable with the independent variable. And that has to be checked. And here we see it's fine. It's not significant, which would indicate that the scales are not fitting. When we execute multiple regression, we enter not only one variable, we enter the control variables, team tenure and gender, and the 2 explanatory variables, centrality degree and centrality betweenness, all 4 our independent variables. Creativity would be our dependent variable. And again, a regression draws a line, but in this multiple regression, of course, it's multi-dimensional. It's not as easy as in a simple regression. So we see an explained variance now with 4 variables, which is 0.387. We also see a F value as with the original simple regression, which means our model is 12 times better than taking just the averages of the independent variables. And we find the coefficient and we find the significant, and we see that centrality betweenness or betweenness centrality, it's highly significant, and the other variables are not. And we have a collinearity statistic, the variable inflation factor, which should be lower than 10, and we see we don't have any multicollinearity. This model is valid. What does it explain? When we take our two hypotheses, saying the degree centrality negatively impacts creativity, that would be one-sided, because it's not, we indicate that's negative. Hypothesis could also be degree centrality impacts creativity. That would be two-sided. In our case, it's one-sided. When I go back to the slides, we find a significance of 0.164. This significance is always two-sided. If we test one-sided, saying positive or negative in a hypothesis, we can divide that by 2. So in reality, our significance here would be 0.8 and would be smaller than 10%. In certain circumstances, you might also count that as being valid and saying that's significant, and I report that. That depends on you as a researcher, how much likelihood you want to take or how much risk you want to take to make a mistake, 5% or 10%. Here you take 10% risk in making a mistake by taking 0.1 as a cut value when you do that. And then we say we test one-sided and not two-sided, as it is always displayed in statistics. One-sided or two-sided testing, here again, you see this 0.64. That would be two-sided. Divided by 2, it would be 0.08, and in this way it would be significant. Coming to the logistic regression, same procedure. It looks a bit different, but for the rest, it's almost the same. You enter these variables, you get the coefficient, you get a significant value of your whole model. In this term, not the F value, but a volt value, and we find approximation of R square, the explained variance of 0.477, 0.48, if you want to have it like that. We find again the variable between centrality highly significant. And all our other variables not. What's interesting is also the constant. It has not to be significant. Actually, you can take it out. It depends where the line starts in your diagram. If it is significant, leave it in. If it is not significant, you can take it out. But for the rest, the logistic regression works actually, and it can be interpreted in the same way. You have the coefficient, you have the model quality, you have the explained variance. The explained variance here is only an approximation. So, thank you a lot. I hope that this extension from a normal regression towards multiple regression and logistic regression helps you to understand that. What's important is that you have to test all variables when you enter in a regression of a normal distribution. You have to look at multicollinearity. That means that independent variables do not correlate too highly. And you have to look at heteroelasticity, whether the scales match to each other. But you find the tests I have shown in any decent statistical program, so that you can execute these statistical procedures and you can interpret it as tables in scientific articles. Thanks a lot for listening.